Welcome back, Honors Kids. I apologize, my videos keep canceling out. I actually already did a video on this one, but it canceled out, so I'm going to walk you through this one again, just hopefully my video holds true. All right, so I did 3 and 4, and so what I wanted you to notice on number 3 is that the first thing I want you to notice is that it's an infinite series, because of the infinity sign. We are finding the sum because of the summation, and that we should recognize that it's geometric because the r value here is being raised to a power. So this is the sum of an infinite geometric series. So that's how you know what you're trying to figure out. The first thing you need to do in anytime you figure out the sum of an infinite geometric series is you need to check that the absolute value of r is less than 1. So in this case, our r value is 3/5. And so you have to ask yourself, is the absolute value of 3/5 less than 1? And the answer is yes. So once you know this to be true, then you can go ahead and plug it into your formula. So the sum for the infinite geometric series is s equals a sub 1 over 1 minus r. Your a sub 1 is always when you plug in this value here, whatever this number is, plugged in will always give you your first term. So I get 6. My r is 3/5, so I get 1 minus 3/5, and so I get a sum of 15. I also talked about number 4 because I wanted you to notice that this has no sum. And the reason why is because, yes, it's infinite. Yes, we're figuring out a sum. We have an r value, but the absolute value of r is not less than 1. So r is 2.5 over 2. And so the absolute value of r is not less than 1, making it not possible to figure out that sum. You could figure out a partial, but you can't figure out the full sum of that one. Let's move on to number 7. So this is a story problem. It says a child pushes a tumbler toy and lets it swing freely. On the first swing, it travels 30 centimeters. On each successive swing, the toy travels 75% of the distance of the previous swing. So it's like this. So basically what happens is the distance keeps decreasing over and over again. So it's converging, right? So this is an infinite geometric series. So on the first one, it's 30. And the second one is if it's 75%, that means what you're telling me here is that's our r value. So it's 75% of the total distance. So in this case, 75% of 30 is 22.5. And then we could continue on. We don't really need to, but we could. What I'm trying to get you to do here is recognize that this is an infinite geometric series. Once you figured that out, all you're really doing now is plugging it into your equation. So we know that our absolute value of our r is indeed less than 1 because 0.75 is less than 1. And so now we're just going to plug in what we know. So we know 30 is our first term. Our r value is 0.75 or 3/4. And then I do the math and I get 120 centimeters. I'm going to also do number 8 with us. And so number 8 talks about writing a repeating decimal as a fraction in simplest form. What I'd like you to think about this repeating decimal is think about, okay, so what's repeating is the 12, right? 12 keeps repeating over and over again. So if I wrote this as a series, I would have to write it as 0.12 plus 0.0012 plus 0.000012 and so forth and so on. So what I recognize here is that my r value is 0.01 because that's what I'm multiplying by each time. So if I wanted to write this as a fraction in simplest terms, I'm going to figure out the sum of this series. So this is an infinite geometric series. The r value is indeed less than, the absolute value of r is less than 1, so we can figure out the sum. My first term is 0.12. My r value is 0.01. What I get here is 0.12 over 0.99, or in other words, if I reduce that fraction, I get 12/99ths, and if I reduce it even further, I get 4/33. So that's how you figure out kind of like the fraction. An easier way of doing that is to literally just put it into your calculator. So I know this is probably the cheating way of doing it, but another way of doing this is to do 0.121212. Just do this a whole bunch of times in your calculator. And then once you have that in your calculator, to be able to figure out the fraction, so I hit enter, I'm going to do math, enter, enter. Enter, enter. and notice that I get the same answers I did on my paper. So this is the cheating way of doing it. Well, it's not really cheating, but it's like, the easier way of doing it is to figure out like just put in your calculator and hit the math, enter, or you could do it by hand by looking at the sum. All right, I think that ends our video for today. I apologize for all the breaks. And if you have any questions, as always, make sure you let me know. Bye for now.